Today's agenda is a good one that's going to cover all the various capabilities inside of ArcGIS to process that raw imagery and turn it into a source of authoritative information that you can use for base mapping and other GIS type of analysis. We're going to briefly start with an introduction to ArcGIS and the photogrammetry capabilities. Then we're going to get a product demo of Drone to Map. From there, we're going to talk a little bit about our new Ortho Mapping for Pro and OrthoMaker for ArcGIS Portal. And then we're going to give product demos of those two things. And then we'll wrap up with some conclusions and some questions. The most important thing I want to point out is that as we go through this presentation, even though the audience is on mute, please type any questions you have into the chat box down in that little question panel. And towards the end, we'll start working through and answering some of those questions you have. If it happens that we do run out of time, we will respond by email to any other questions that we don't get to during the question and answer session. So before we actually get started in the actual agenda, what I'd like to do is ask a first polling question, just to gauge, a little bit of the audience on what your level of experience is with photogrammetry. So if we could open the polls, that would be great. Okay. So it looks like the audience is voting. And it's a very good response. So you can look at the results down in the polling questions. We do have a mix in the audience of different levels of skills, and so this is perfect because this is exactly how we've tailored the presentation. And so let's go ahead and move on to the next slide. And the reason why I want to show the next slide is just because we got the right level of skills on the team presenting today to help respond to any types of questions that you might have. Mark Romero is our imagery specialist here at Esri. He knows how to make ArcGIS dance and sing with all the imagery capabilities. And so he's going to be giving presentations on Drone to Map and those capabilities from that particular product. Steve Lambert's our certified photogrammetrist. He works on the professional services team, and he's going to take on and demonstrate some of the more advanced capabilities of ArcGIS Pro and our OrthoMaker for Portal. And then myself, I lead the business development for imagery at Esri, and I'll be happy to answer any of those lesser technical questions, but certainly the ones that can help you set up a proper configuration for the different types of photogrammetry that you might want to do. Here at Esri, the thing that's very important and the thing we focus on is the science of where. And what's very cool about the science of where is it's a way to connect up everything. And of course, sometimes, when your only tool's a hammer, the whole world's a nail. Imagery guys tend to think that way, but it's very, appropriate for the science of where, because the ability to connect up all these different remote sensing capabilities, whether it comes from drones, satellites, or aircraft, is a key part of what our platform is all about. So the science of where integrates dynamic data about everything, and remote sensing is a big part of that. And for those of you who aren't aware, we've made significant efforts in the past few years towards our imagery, our remote sensing, and our photogrammetric processing capabilities. And this new imagery platform is plugging very well into the science of where framework. And this framework, if you hadn't heard it before, has three critical parts: a system of record, a system of insight, and a system of engagement. And how imagery kind of overlays that is that your system of record is your authoritative data. This is where imagery management comes in really strong, because as you go in and process your raw imagery and then publish it and make it available, that information is authoritative, and you can use it for all types of things, whether it just be simple base mapping or actually extracting features out of the data. So having that authoritative content is really important. We are expanding our imagery analytics capability to do more and more automated feature extraction. Lately, we've been working on a significant AI capability as well. And you'll actually see that later on in the imagery series that we're doing as part of our introduction to all the imagery capabilities in the platform. And of course, the system of engagement, one of the strongest parts about the platform is the fact that we can serve up this massive content of raster and imagery data into different apps and different applications, which in turn can then be shared outside of your domain to a broader use of users. So it's this system of record, system of insight, and system of engagement that we're really working hard to have our platform support. And you can see this is just a schematic of our platform, and not necessarily going into a lot of details, but similar to the things that we talked about is the image server, on the, is down there, and it's the heavy lifter that brings all this data together and then shares it out to a variety of different clients that do this analytics, clients that do this higher end ortho mapping capabilities. Those clients we have are thicker desktop clients like Pro, but we're also introducing a family of lightweight, thin apps that can actually do quite a bit of processing itself. And you'll see an example of that with our new OrthoMaker capability that we're going to demonstrate later on. Just to simplify things though, on the imagery team, we've kind of come in and we focused these into 4 broad categories: imagery management, map production, analysis, and visualization. So as we go forward with our imagery story, you'll see these things more and more. But of course, today's webinar is all about photogrammetry. It's taking those raw sources and doing more with it. And the 3 products that we have that do this are, Drone to Map, which is a standalone app, ArcGIS Pro, which has the complete ortho mapping workflow embedded in it, and our new OrthoMaker software, which is designed to work. It's a thin app that works with Portal for ArcGIS and the image server that lets you do massive photogrammetric processing in the cloud. And of course, this is all about creating authoritative content from the different sources, whether it be drones, aerial, or satellite. And that's where we focused as a group. In today's demonstrations, we're going to see examples from drones. We're going to see examples from aerial. We don't have any today from satellite, but it's a very similar process. We have a very rich library of different satellite sensor models that plug very well into all these photogrammetric workflows. This is just an example of the different derived products that can come off of this workflow, whether it be, digital surface models, orthomosaics from the base mapping side point. The other thing you'll see is like in Drone to Map, it's advanced site modeling capabilities of building these very beautiful, highly detailed 3D site models that you can go in and fly around. And then finally, there's also some other things that are done with kind of inspect and measure, change detection, volumetric analysis, 3D measurements, those types of things. Those are of real interest to the drone flyers that want to go out and do that kind of inspection type work with their drones. And so we're trying to ensure that the platform supports successfully all these different aspects and these different information products that you can get. We've had some considerable success. We have a number of good users out there that are using these products. This is an example of, one of our power users, Will Shewart at Virginia Commonwealth University. He's done projects as large, this one's only 1,200 images, but he's done projects as large as 2,400 images in a block that he's turned around and processed and made some of these, these different site models that he does. So the one thing as we come forward in this presentation is that we're very confident in the ability of our products to work with large amounts of data and provide the information results that you need as an organization. So for those of you who have a little bit limited experience with photogrammetry, the question is, why do we go through this process? Why do we go through this work? And so this is kind of a layman's description of how it works, but if you take an aerial photo and you were just to put a map grid down on that aerial photo, you'll see that building right in the center port of that photo, well, it's looking like it's straight down. You can't see the sides, it's definitely straight down. But look off to the right at that building to the right, and you'll see that the top of the building is actually at a different location than the bottom of the building. So if you were to actually put a map grid right down on a photo, even if it was taken perfectly straight down, you're going to get this effect called relief displacement. And the further objects away appear from the center port, the more they lean over. Now, it's very dramatic and very apparent when you look at a high-rise building. But the real truth is hilltops do the exact same things. Mountains, hilltops, and then depressions do the opposite way. They will always, the further they get away from that center point of that imagery, the more and more relief displacement occurs. And so that's really the first goal of photogrammetry, is correcting for that relief displacement that comes out of the center part of the image. The other thing that can happen is, you kind of make this assumption that, the sensor is looking straight down. But the real truth here, it rarely is looking straight down. Aircraft, drones, they're bouncing all around. Satellites themselves are extremely stable, but even then, if you think about it, because they're so high up, that line is so long that there can, that blowing down to the ground. So even if they're just a tiny bit off, that center point can be off, fairly substantially. So there's all these different ways that you have to correct for these, and you have to look at these rotational angles to get the results that you're looking for. The thing that helps you the most do that is overlapping stereo images. So we're going to talk about, when you go out and collect with drone and map, having that stereo overlap is very critical, because with each photo that you'll take, there'll obviously be a center point. And from that center point, you can establish a local coordinate system or an image coordinate system. But then how do you link these photos up? And you do that through a process of building up tie points. And what's nice about the software that Steve is going to show you, and Mark as well with Drone and Map, is you can have this system automatically find these tie points for you. And essentially that connects up the different image coordinates on the different images that make up your block of photos. But then what's really cool is that you can tie those image coordinates down to ground control, down to ground coordinates using ground control points. So that's how you tighten that information down to the ground. But then when you go back and you look at the relief displacement, and you can see it on the steeple of this church here, in one image, the steeple's almost coming straight at you. The other one, it's leaned over. Well, you can measure that parallax in the stereo. And that's how you measure and start working out and taking out the different parallax associated with that relief displacement. Then we use something called cross correlation, and what that does is it automatically goes back and forth and finds all these tie points back and forth on the imagery, calculates the difference in elevation, and hence you get a DTM, a DSM, a digital surface model that you can then use to do the ortho rectification. So that's kind of how photogrammetry works. The traditional model is built around trying to look straight down as possible from your aerial photos. You want those photos taken as near nadir as possible. But the new approach, especially with drones, is the fact that you want to create these very dynamic 3D models. So we use something called structure from motion. And this is just more advanced photogrammetry that doesn't necessarily require that those images be taken straight down. They can actually be taken obliquely or off to the side. And so you can fly around a building, get all the different sides, and produce these very nice 3D models, if you will. So, and then of course, from the result of all this information, you want to make sure that the end result is authoritative. So you want to see these reports that give you this good information, that show you the errors. And so then if you need to correct or if your solution meets a minimum requirement that you're trying to achieve. Now, before I turn it over to Mark to talk about drone to map, let's go ahead and ask the second polling question if we could. And so we'll get to open the polls. And so we're just kind of curious, for those of you who've been around photogrammetry, what other photogrammetric packages have you used before? Excellent. Well, that looks like a great result. Thank you for sharing that information with us, and that helps us understand the types of things that you're used to doing with your photogrammetric capability. So at this point, I'm going to turn it over to Mark, and Mark will talk about drone to map.
Okay, thank you, Kurt. I'm going to jump right into a couple slides and talk a little bit about the product, and then I'll jump into a demo. And so, as Kurt said, Drone to Map is our product for processing drone photos, and it's a standalone product. It actually runs independently of any other ArcGIS product, so it's not an extension, it's not an add-in, and it runs on Windows, and it's really designed with a nice, simple interface in mind, and with one idea, and that's to take your raw photos that are coming off your drone, feeding them into the product, and then generating the different GIS ready products that that Kurt talked about. And you can see those include the 2D map images, the 3D elevation products, and then finally those smart inspection photos. One of the main differences between drone to map and many of the other drone processing software out there is that drone to map is tightly integrated with ArcGIS Online and Portal. And although it does run as a standalone product, many of the products that are generated from drone to map can be directly served out as image services, or the point clouds can be pushed up also in a 3D scene. And so the integration with ArcGIS Online just makes it easier to share your products and disseminate them to anybody that might want to see those results. This is really the whole workflow from beginning to end of flying the drone and creating products. And so this is an acronym that we've taken from that's popularly known in the defense and intelligence remote sensing community. And this is TCPED is what it's referred to. And this is tasking, collection, processing, exploitation, and dissemination. And so the tasking part is really just the flight planning part. This is programming your drone to fly the way that you want it to and collect the photos. And so these first two steps, these are not capabilities or products that are built into Drone to Map or ArcGIS. These are steps that we leave up to our partners or their third-party vendors. And so really the manufacturers of the drones create their own flight planning software, for example. Once you get into the processing side of things, this is where the ArcGIS products come into play. And so again, we're talking about Drone to Map to process the raw photos. The exploitation, once the products are generated, they can be pushed out to a more powerful desktop GIS application like ArcGIS Pro or any other remote sensing application that you may use. And then finally, that last piece, the dissemination, that's just taking your data and sharing it out via the web or any other means. These are the two flight patterns or collection patterns that are typically used for most drone operators. And so the one on the top left there, this is typically what you'd use to generate the 2D products. This is, some people call it a lawnmower flight pattern, where the drone is flying up, taking photos, back down, and then back up, and then you'll get that overlap from each subsequent photo. The one on the right is a flight pattern that is typically used for capturing 3D content or generating some sort of scene or model over a particular object of interest. And so between those two and a combination of using some ground control points, we can get some very accurate both 2D and 3D products. Okay, so I'm gonna jump into the demo. Okay, so I've jumped right into Drone to Map, and so this is the interface. And to get started, really all you do is choose your product that you want to create, and then simply navigate to the location of your photos on disk, and then that loads them right in. So you can see I've got a big list of photos here, along with their geolocation information, lat, long, and then the altitude of the drone above ground. And so once I've got that, I can just hit OK. And then that loads all the points into the interface here. And so the first thing you'll notice is a couple layers. You've got this blue, these blue points that represent the geolocation of the photo itself, coming off the GPS. You also have a orange line. This just represents the flight path of the drone as it was taking photos. And those little red X's are the actual ground control points, or the targets on the ground that were used to increase the accuracy and tie the photos down to its true position on the Earth's surface. But to get started, really, the first steps are just making sure that the photos are placed in the right location. And I can zoom out. And because it's tightly integrated with ArcGIS Online, you can see that we've got access to all the base map content that's part of the Living Atlas of the World. Go zoom back in. And we can immediately start interacting with the photos themselves. And I can do that simply by clicking on this blue dot. And that brings up a photo viewer of the images from the drone itself. And so think of this as also a QA QC step to make sure that your photos look good and that you don't have any results from things like motion blur or any other things that could go wrong as the drone is taking photos. So this just kind of gives you a sense of also the resolution of the photos themselves. We can also toggle from 2D to 3D, and this gives us a nice idea of the quality of our flight lines as the drone is taken. So again, there's a lot of things. If there's windy conditions, they can modify the flight pattern, and those just gives us a sense or a visualization of those flight patterns from the drone. And so once you've gone through these initial steps, all there is left to do is hit the start button, and that'll begin the process of generating the products themselves. And so I'll go ahead and I've already ran the results here, so I'll just show you, what it looks like. So I'll zoom in a tad. So here's the ortho mosaic. We can see that all the photos are nicely stitched together. They look good. We can also have a look at the DSM and the DTM. I'll actually turn on the DSM, and this gives us a nice sense of the terrain as well. Now, Drone2Map is not really the tool that you're going to be using for analytics. However, we do have some basic volume calculations that are built right into it. And again, Kurt showed this. One of the important aspects of this is the quality or the accuracy of our final products. And these reports give us that kind of information. And so this tells us all kinds of stuff about our flight, the photogrammetric process, and then the accuracy results as well. So once you've done that and you're satisfied with your results, all that's left to do is decide what you want to do with the data. So because these are written out on disk as standardized raster formats and 3D content standardized formats, we can start using these directly in any GIS application or remote sensing application that we choose. So we can open the file directly on disk, and you can see I've got a collection of tips there for the ortho mosaic. The 3D content, I can start working with the point cloud as well. But at this point, I also have the option to share this data. And so I can take my 2D products, and with one button, if I'm logged into my ArcGIS Online account, I can choose to click these tools here, and these will push the data directly up to ArcGIS Online. And so I can pick the scales, the products that I want, and then just hit the OK button. All that processing will happen in the background. Once the data is on ArcGIS Online, that just opens up a whole nother set of capabilities. And one of the nice capabilities of ArcGIS Online are pre-configured web mapping applications. And so these are applications that you can configure that don't require any coding. And so here's an example where I've brought in the world imagery base map going back to all the way back to 2014. We can click through and see change through the different years. And then finally, I'll turn on the drone processed image that we generated. And then I can compare this one to previous years. So I'll click this swipe button that I configured, and this just gives us a sense of, in this case, on the development of the construction of the bridge. And so while we're here, I'll go ahead and switch over to a 3D web map. And so we are taking the point cloud that was generated from Drone2Map. And so you're actually looking at the point cloud there. And so it looks very realistic, photorealistic, but it actually, in fact, is a point cloud. And so as I start to zoom in really, really tight, you can start to see those points. But it also gives you a sense of the density of the point clouds that are coming off one of these photogrammetric processes. And then so in addition to that, we can switch between different views of this. So if I want to switch from kind of this true color to more of a render that's displaying the heights, we could do that as well. And we can actually query out the height values simply by moving this histogram up that queries the different heights. So if I wanted to see everything above 429 meters, for example, I could move this up here, and that'll redraw those points, and then I can start to see these trees that are higher up that go above that elevation. So different ways of interacting with the point cloud as well in 3D. And then finally, I'll just show an example of, and I just gotta move my, there we go. I'm using a measuring tool, and I can actually take heights or measurements from in between two different points on the map in 3D. So my last demo is just going to simply show you a way that we can take another type of flight, in this case an orbital pattern or a kind of a pattern around a particular object of interest to generate some 3D content. And so what you're looking at here is a small building in California, and you can see that the flight pattern, we took 3 different levels, 3 different heights to capture really all sides of the building. And so when we zoom in there, we can get a sense of what the final product looks like. And so you can see once we capture all sides of this building, we can get a very accurate 3D representation or a model of that object that we're interested in here. In this case, it's just a little shed that we have out in California near the Redlands campus. Okay, so that concludes the drone to map demo. I'm going to turn this back over to Kurt.
Thanks, Mark.
Thanks, Kurt.
As we switch over the, okay. Thanks, Mark. Hopefully everybody can hear me and start to see my screen. So that was a great presentation. It really shows the power of drone to map. But now we're going to talk about some of our other photogrammetric products that we've recently released, as part of ArcGIS and the platform. So we're going to talk about ArcGIS Pro and the ortho mapping workflow, and then also the OrthoMaker, which is a standalone app that's designed to do this massive processing inside a cloud type of environment using Portal. But before we go this, let me point out a few things, because people might have the question of, well, why would I use, ArcGIS Pro over drone to map, or however those questions, why do we offer all these different choices? Well, the key thing to understand right now is that the ArcGIS Pro and the OrthoMaker do not have the structure from motion capability in it yet. So what we recommend is that for the current releases of the software is that you, if 3D and 3D site modeling is critical to you, then focus in on drone to map and use drone to map. But as time goes on, that whole ability to do more and more advanced 3D stuff is going to be carried over into Pro and the OrthoMaker as well. And so right now, if you want to do a lot of 3D, look at drone to map. If you want to do very rich high-end photogrammetry for base maps, and if you're dealing with lots and lots of different images or historical images or aerial photography, then you want to look at ArcGIS Pro or OrthoMaker. So that's just a way to distinguish between those two. Now, before I go into these two products, let's ask our final polling question. And this just talks about what are some of the sources of your imagery that you might want to process. Excellent. Well, a good mixture of results there. I'm really excited to see all the different folks that are flying drones. All 3 of these software packages can be used for the folks out there that are doing drone flying. Like I said, you'll be better off having if 3D is critical to you, use drone to map. But if you're dealing with lots of photos and want to start setting up a more rigorous, powerful capability that can leverage distributed processing, start looking at ArcGIS Pro and, of course, how that flows into OrthoMaker. So let's introduce those products right now. And before I turn it over to Steve, just to give you a little bit of background about those 2 particular products. So the ortho mapping workflow is a built-in part of ArcGIS Pro. And it allows you to work with, drone imagery, aerial and satellite imagery, and do essentially block bundle adjustment of those photos. And you can see this is the particular workflow itself. It's very straightforward, works on a desktop, and so it produces great results. You can see this is the interface, and Steve will go into more detail on this. It's essentially a wizard-based workflow. The first thing is to come in and have it automatically do that adjustment, find those automatic tie points as after you've brought in the center points of the imagery. We've done some really unique stuff with. Oh, okay, I guess we have a technical glitch that we're not seeing the screen, so hold on for a second. So hopefully folks can see my screen now. Okay, excellent. My apologies. So let me just back up one slide. This is the overview that I was talking about, going from the different sources flowing down into the adjust process, out to the different products that make up the that come from the output of the photogrammetric process itself. And then this is the slide that talks more about the actual user interface for ArcGIS for the ortho mapping workflow in ArcGIS Pro. You can see, as I've talked about before, that this is a wizard type interface that takes you down through the adjustment options, the block bundle adjustment. It lets you go ahead and manage and add ground control points for a much greater degree of accuracy to tie in those ground control points rather than relying on the accuracy of the GPS of the sensor. So you can tighten that down with survey. We've also added a set of tools that Steve will talk about that can actually work with fiducial data to help you work with historical aerial photos as well. And Steve will give an example of that. And then, of course, this is where you can select the different outputs of products and set the specifications of how you want that output to work. The other great capability of the ortho mapping workflow itself is our new stereo imagery capability that allows you to work and take those overlapping photos and produce stereo photos that you can do feature extraction from directly in Pro. This is the capability that comes with the image extension for ArcGIS Pro, and it allows you, as I said, to have the full ArcEdit capabilities of going in and extracting 3D objects and working with that as part of your GIS. I'm not going to talk much about this today simply because you don't have stereo glasses and you wouldn't be able to see the capability. But I just wanted to make sure everybody knew that functionality was there, that you can actually do full stereo collection type work. And then finally, the OrthoMaker. And this process is a little bit different. As I said before, it's a thin client application. It works as part of Portal. It allows you to take your imagery from your different collection devices, push it up into a cloud or push it up to a system on premise, and then actually do distributed processing to produce those products. So if you have large amounts of data that you want to do and leverage this distributed processing of the cloud, this is the tool that you want to consider using. And you can see it's a project-driven solution with that direct upload to the cloud. It has the same block bundle adjustment that's in Pro, but it's operating as part of Server. So you can do that different adjustment to your data to get it correct and tight. And then it has the same similar type output products, whether it be DSMs or ortho mosaics. The other nice thing is that because this is a cloud operation, as soon as it's done, there's really not even really publishing. You just point to it. It sets up the image service automatically. And so the data is already in the cloud or on your server, and it can be made instantly available to your organization. So with that, I'm going to turn it over to Steve, and hopefully, Steve, you have better luck sharing your screen than I did with that last pass, but we'll let you go, and we're looking forward to seeing these new capabilities.
Okay, thanks, Kurt. Hopefully
I can see your screen, so you're good. You're good.
Thanks. Hello, everyone. I'm going to take a slightly different tack than Mark did earlier and look at the application of the ortho mapping workflows in ArcGIS Pro and Desktop to historical data. ArcGIS tools have supported satellite data, digital aerial data, and even drone data now for many years. And you know, consuming that data is fairly straightforward. We've got tools that allow you to bring it in and analyze it. But historical data sometimes creates problems. And so I thought today we'd look at an example of how you might use these tools to be able to create essentially operational products from this historical data. And this is of real interest now, looking at climate change and change detection and land use management and all sorts of different time-based analyses. So we're going to look at data that looks much like the image I've shown here on the screen. This is a photograph that was provided to us by Missouri Department of Transportation. And it was a use case where they were looking at doing some realignment work on this interstate highway interchange. You can see this data was taken in 1996. It's relatively large scale. It's 1 to 6,000 scale. So we're going to go ahead and look at the process of taking content that looks like this and creating operational products from it. So in order to do that with this scanned historical data, we need to create a table that has some very basic information in it to start off with. In this case, we're going to look at just 3 photographs, a simple stereo triplet, just in order to make the file sizes small and the processing time fast. I've taken the first row of my data set and copied it and transposed it here so you can see the attribute fields that we need to have initially to sort of help define the information about the content. So we need a file name, we need a camera, we need to know where the file is located on disk. We need to know a little bit about an approximate position of the image, some estimates for its orientation. Very critically, we need to know what the scan resolution is. And so this is driven by either scan vendors or you having an in-house scanner to collect that data. We also provide the ability to put in the focal length and any camera calibration data you may have from a USGS camera calibration report. And so you create a text file, a simple CSV file that looks like this, to help drive the ArcGIS Pro product. So let's go ahead and look now at Pro and show you what that looks like. So I've got ArcGIS Pro here. I've replicated Kurt's color theme, so I've got the dark theme, not the light theme. And this is just a blank project. The only thing I've done here is I've added folder connections here on the right to where my data is located. So let's go ahead and get started. As you know, in ArcGIS Pro, the imagery tools are now directly on the first page of the application. And so if you click on the imagery menu item here, you'll see that most of them are currently disabled. The one that's not is the one on the far left, which is a new workspace. Now, the ArcGIS Pro image processing and ortho mapping workflows operate on this concept of a workspace, which is a subset of an ArcGIS Pro project. And in order to do the processing, you create a workspace to collect the information about your data set and the products. So we're going to go ahead and create one here. We're going to call it live, not lice, live, OM. And as Kurt mentioned, the ortho mapping workflows support multiple types of content. So it supports drone data, satellite data, digital aerial data from either a fixed wing or a drone, and also at the bottom, scanned aerial, i.e. historical imagery. And so we're going to create a workspace that has historical imagery in it. And so you give it a name, and it brings you through this very quick wizard. You point to the table that has the metadata about your project. And so here's the one I just showed you a moment ago. You define the spatial reference in which the data is represented. In our case, it's just Web Mercator and NAVD88. The processor has already read the metadata and identified one camera in the collection. And so if you click this, you have the ability to add a little bit of metadata about the camera. This is the Zeiss RMK film camera. You put in the focal length, and these are all in units of microns. And then you can define the scan resolution, which I know in this case is 14 microns. So I hit OK, and then finish. And what ortho mapping is now doing is it's reading the image collection, it's creating mosaic data sets, it's populating initial metadata, and it's creating the framework in which we can begin to do our processing to create the adjusted block. So you can see here, it logs what's going on, it creates a base map for you. And in the table of contents on the left, it shows you all of the items that we'll eventually be creating as part of this workflow. So it's loading the 3 raster data sets, it's building statistics, it's creating the mosaic data set, and it publishes it to a base map. So here now we see the essential footprints of those 3 images. And you can see here the image shows the very same intersection that we saw on the image a moment ago. Now at this point, we haven't really done any processing. All we've done is created a container to do the work. And if we now go to our ortho mapping menu, which has now been enabled after we created the workspace, we see that we have some additional capabilities here. As Kurt mentioned, one of the things that's unique about aerial imagery, this historical data, is that it has calibration marks in the image format. And we want to be able to take advantage of that information to be able to refine our process. So as part of ArcGIS Pro Ortho Mapping now, we have the ability to actually measure fiducial marks, which is something that was not previously available. And so it's read a little bit of information about our imagery. And now we can actually go back and look at the entire image. And so here's the same image I just showed you a moment ago. I'm actually going to go and measure the fiducial marks interactively. So you can just zoom into one of the corner fiducial marks, and this is sort of a typical shape of a fiducial. The calibrated coordinates are where this dot is. So we're going to go ahead and define a little search footprint around those dots and have ArcGIS Pro's ortho mapping measure the fiducials for us automatically. So I've created a template. I can look at what that template looks like. And then I can say, go ahead and measure the fiducials. And so it's going to go and process the entire image collection and apply the fiducial coordinates to it. So again, this is a new capability that was not available previously in desktop or Pro. So once we have the interior orientations done, we can define some basic parameters about how we want the adjustment to be done. There are only 2 items that you really need to care about here. The first is the resolution at which the tie points will initially be extracted. So if you have historical data, usually we prefer to set this at 8x the resolution of the source data. And in our case, I simply took the photo centers off a base map visually, so I don't expect that they're terribly accurate. So I'm going to set the accuracy to be very low. Now for historical data, it didn't really involve any GPS. It just refers to how well do you think you know the initial estimates for your photo center coordinates. And I don't think I know them very well, so I'll set it to low. And those are the only adjustment options you need to define. And then you can immediately jump into the block adjustment. So I've started it off. The block adjustment for historical data is a 2-pass operation. So it does an initial pass at coarse resolution, that is the 8x pyramid level for this imagery, and extracts tie points. It computes a preliminary relative orientation for all of the images and does an adjustment using those tie points. Once that's done, it will go back and redo the tie point extraction at full resolution of the imagery and refine the initial estimates for the adjustment, and then create a final set of tie points that will be used for the final adjustment, the integration of ground control points, and the creation of the output product. So you can see here that it's already started the initial tie point. This one should take about 35 seconds or so to do. And you can see it's already done the first one. It's applying the block adjustment, and now it's already computing the final tie points. Now, the reason I chose such a small data set is that we could actually watch it in real time. So let me just shrink this down a little bit. And so now it's actually done the final block adjustment. It's applying it to the mosaic data set, and it will update the shape and the orientation of the footprints. And so in a moment here, it'll redraw and show you that we slightly have a different alignment here, just a little bit. This was flown at about 45% NLAP, a little bit smaller than we normally would like. But we have a preliminary adjustment, and you can actually look at the adjustment report here for this analysis that was done with no ground control. Okay, so this is sort of a preliminary adjustment. As Kurt mentioned, once you've done the initial adjustment, you now have the ability to bring in ground control points. And so we've built in a user interface to allow you to either interactively collect ground control points or to import a data set. So if you have existing ground control points that you want to import, you can import them from a text file. and define the fields that contain the X, Y, Z and the point labels. You can also even include photographs of the ground control points if you have them. In our case, I'm not going to bother to import any ground control points. I'm just going to choose some interactively. As Mark mentioned, because this is also integrated with Portal, you have the ability to access all of the various base maps that are in the background. So I'm going to turn my imagery layer off, and I'm going to go ahead and add a control point. I'm going to add a control point right here. I'm not going to be terribly careful about this so we can get it done quickly. And so what it has done is it's gone back and interrogated the world imagery base map layer to get an XY, and it's interrogated the world terrain elevation data set to get a Z for the location that I clicked on in the base map. And at the same time, it's identified the images on which this point should appear. So if I come down here to my image file, I can zoom out a little bit, and lo and behold, here is the same intersection that I just collected. So I'm going to go ahead and measure this control point right here and mark it there on this image. And it will try to correlate all of the other images for which that point should fall on, but it doesn't always find it depending on what your initial estimates were for your orientation, but I'm going to go ahead and measure it. So there's one ground control point. Typically in photogrammetric block adjustments, you like to have ground control around the perimeter of your block. So I'm going to add another point here at the end of the fence line here in the drainage ditch. And I want to measure that one as well. Again, I'm going to do these relatively quickly, so bear with me if the final results reflect my speed here. So I'm going to say it's about there. And I'm going to add 2 more points at the other corners. So this is 3 photographs, and we want essentially the center photograph to cover the area of interest for our mapping project. So I'm going to add another point here. You need a minimum of 3 points. You can add as many more as you like. Oops, let me come over to my window here and remeasure this control point. And you can see here, I can just pan over a little bit. It's right here at this intersection. I measure that one. I measure the other imagery that it's on. And it's right here. And finally, I'm going to do just one more point. I'm going to choose this point up here on the overpass. So I'm going to add a point here. And then on the overpass here, I'm going to zoom out a little bit. And you can see that it's right here on this point. So I'm going to put it there. And I'll measure it on the last image right here. So at this point now, we have 4 ground control points in the overlap area for our imagery. All we need to do to integrate that ground control point into our adjustment is simply to rerun the adjustment. And what happens is ArcPro tells you that there was already an adjustment created from the tie points, but it's building in the additional ground control points that we've measured. And so it does that. It recomputes the block adjustment. It applies that block adjustment to the block. It looks like I missed one here. So this point didn't fall in the stereo overlap area. I probably should delete that one and redo it. But I won't take the time to do that at the moment. So that's the workflow, essentially working from left to right. Most of the block triangulation that I've ever done in my life is sort of this recursive process of refinement. And you would go through and refine your tie points. You would edit points out that were not, that had high residuals. You may add and remove ground control points. And when you're done, you can then use the results of that adjustment to create models. And so just as Kurt pointed out, this is sort of a wizard-driven workflow. You can create digital elevation models for the stereo overlap area, or you can create orthomosaics, or you can do a combination and do them all at once. And you can choose which of these you like. In addition to the orthomosaic, there's a seam-line processor, and it allows you to do color balancing and then to do the generation of the orthomosaic. And so this is the process then that gets run to create the output products. And since I was a little bit sloppy with my measurement, let me just show you the result of what that looks like. in the actual data set. So let me refresh this. So as Kurt mentioned, the data gets put into a standard location on disk, and you create these output products, and then you can go ahead and display them and serve them up in ArcGIS as well. Let me go ahead and run it, knowing that this point's going to be a little strange looking, but go ahead and do it anyway. Most of the default settings you can take directly for the seam lines and the color balancing and the output mosaic. And so it's going to go ahead and run through this process and create a mosaic file for you. This takes about a minute to run. And the idea is that once you've created these products, just as Mark indicated with Drone to Map, because this is integrated with Portal and ArcGIS Online, you can take and actually publish these data sets directly to your online presence, either through the Portal or the ArcGIS Online footprint. And you can see here that it does a block adjustment, it computes the statistics for color balancing, it applies the color balancing, and then it will extract the ortho mosaic and create that for you. So that's sort of the workflow. Now the workflow for other data types, satellite, digital aerial, and drone data are exactly the same. You ingest your data, you define some basic options about the adjustment, you run the adjustment, you add control points if you wish, and then you can go ahead and create the output products. And again, as Mark showed with Drone to Map, there is also the ability to view the adjustment report, which is still being built here, so I couldn't show it to you. But that's the basic workflow. And again, the idea is that it's relatively lightweight, it's easy to follow procedurally, and you essentially go from left to right in the ribbon interface to create your output products. So seeing as the clock is marching on, we'll come back to this one. I'll let it create the ortho mosaic. And I want to change speeds a little bit and look at a new product. And this one is called Ortho Maker. And Ortho Maker is a lightweight web app that is a free web app. It comes with ArcGIS Portal. And it came out at 10.6.1 just earlier this summer. And essentially, its use case is defined for the ability to do drone processing using no installed software. All you need to do is to connect to a portal and log in through a browser and create a new project. So I'm going to go ahead and do that. So I'm going to create a new project here. I'm going to browse to where my data is located, and it's on my desktop. And let's see, we're going to take this one. So I've chosen a very small data set, again, in the interest of letting this run quickly. These did not have EXIF tags, so I'm going to load the exterior orientation, the geolocation data from an external file. And so you can see here that it reads the tags in the file. And these are the standard EXIF tags. I'm going to go ahead and create just some basic information. Let's see, this is what 9/27. I may not have the right date, but that's okay. And here you get to choose which processing do you apply as you load the data. So I'm just going to do a full adjustment and not create any output products to start with. And then you literally just hit create. What the Ortho Maker application is doing is it's uploading the imagery to your portal location, i.e. your My Content location. And it's actually starting the block adjustment already. So it creates the image collection, it actually creates a mosaic data set, and actually publishes a service for that mosaic data set. And it begins the adjustment process immediately. So the use case here is if you have multiple field crews working out in the field and they're away from the office and you want them to be able to push data up to the enterprise, this is a very convenient and lightweight footprint for them to be able to do that. So they could connect via the internet at the hotel at night, push their content up, and do an initial evaluation of the coverage of the drone data and the coverage of the ground control points. So again, it's already uploaded the data. It's created a mosaic collection very similar to Drone to Map, and it's doing the block adjustment. Now the difference is that the OrthoMaker is executing the exact same code base that I just showed you running in ArcGIS Pro, except for the fact that it's running in a server environment as a geoprocessing task. So because of that, you can take advantage of a distributed, highly robust and scalable processing environment for large data collections. Pro tends to be centric to the client that you're running it on, but OrthoMaker can take advantage of a much larger infrastructure deployment, if you have one, to be able to do distributed processing in that environment, which makes it kind of nice. So it's doing the block adjustment now, and it will result in an adjustment report just like we have in our GIS Pro. And then we can go ahead and create the output products. Now, again, as Mark mentioned, Drone to Map is tightly integrated with Portal and ArcGIS Online. Well, this application actually runs inside Portal. So it's not integrated, it's actually in there. And so in this case, you can see that I've done the initial adjustment. I can look at the processing report, the block adjustment if I want. And it shows me all of the results here and the log file. I can change the base maps. I can turn layers on and off, but I haven't created any products yet. Once you do the initial adjustment, you have the same ability in the OrthoMaker application to input ground control points either from a file or from the base map. I'm not going to take the time to do that at the moment. I'm just going to go ahead and create some output products. So I'm going to go and create just the Ortho Mosaic. And you can see here that if I want to modify the basic settings, I can do that. If I want to have a little bit more granular access to the settings, these are the same ones that occurred in ArcGIS Pro. I can set them here, or I can just take the defaults and say create. And so the create Ortho Mosaic process here is doing the same thing that we did in Pro. It's creating the seam lines, it's going to do a color balance, and it's going to do a mosaic of these images to create a seamless mosaic. Since it's doing it directly in Portal, you don't have to serve, quote unquote, the data up, it's already there. So you can open the resulting image in an ArcGIS JavaScript viewer, you can open it in a map viewer, you can open it in a desktop client like ArcMap or ArcGIS Pro. And the nice part here is that the data is already all on the server. So as you begin to collect large numbers of individual drone projects, you have a centralized location where you're managing your content, where you're aggregating your data, where you're creating the enterprise authoritative data collection. And then you can serve all of that data out through services and make it available at any desktop client or a tablet client or mobile client. So here it's doing the color correction. This will take just a moment. And now it's doing the Ortho Mosaic. So it's a very similar product line as Drone to Map. As Kurt mentioned, one of the things that OrthoMaker does not do yet are the 3D workflows in Drone to Map. So things like creating point clouds, meshes, and scenes, that part is not yet integrated into OrthoMaker. The focus here is primarily on the rapid and the 2D processing that you would do in Drone to Map. So now you see that I've got my mosaic. I can actually open it directly in a map viewer. And this is accessing the mosaic that I just created. It's in the portal location, and it allows you to view it directly. As soon as my screen draws here. So you can see now that I've mosaiced all of the images together. And the data is ready to distribute to your end users. So again, OrthoMaker is very lightweight. It's got very few buttons to push. And it may have another use case that's appealing to users who are not going to be purchasing and operating their own drones, but are using contractors to collect data for the enterprise. In that case, you could create a contractor access to your portal and have your contractors use this user interface to push content up into the enterprise. So that's another thing to consider. Again, OrthoMaker doesn't require any installation on the client. It just requires a standard browser. It does require a portal access, and there's a portal account. And it's a very nice, lightweight application that allows you to do some fairly sophisticated processing right through your web client. And so I will leave it at that and turn it back over to Kurt.
Excellent. Thank you, Steve. We are now at our 1 hour mark, and so we appreciate everybody that stuck with us. Let's try to go ahead and answer a few questions, and for those questions that we don't get to, as I said, we'll respond to those via email so everybody can have it. I'd also like to remind everybody that this session has been recorded. We're going to send you a link to it, so you'll be able to see this again and track down the different information that might be of interest to you. So just by way of some of the questions here, and this one I think I'm going to answer directly. There's a question about, well, if we don't have ground control points, can I still make a reliable map? And I think that comes down to the accuracy of the GPS that's on board your sensor. So the more accurate that the GPS is in the collection of center points, especially when thrown to map, you can get very reliable results. But one of the other things that, I don't know if we showed it, Mark kind of showed it linking up to the base maps, and we can certainly also do this in the ortho mapping workflow itself, is that we can link to the existing base maps within ArcGIS. So if you're just using a very low cost drone with a minimal GPS on board the sensor, you might want to actually add ground control points from the base maps that we provide with ArcGIS if the resolution is good enough of your area. And that'll tighten down that solution much, much better than just with a very low cost GPS on board the drone. I don't know, Steve, if you had anything to add there.
No, that's correct. I mean, if you're not using any ground control point, you're totally dependent on the accuracy of the GPS processing for your sensor platform. One thing to consider, though, is that you can actually use your drone sensor to collect ground control points if you just leave it on the ground. And that would improve your solution a little bit just by doing that.
There you go. I think another important thing to point out is if you're really wanting 3D, then and if you want that precise 3D accuracy, it's always better to have ground control points that have both X, Y, and Z values, just to get that solution really tight. So Steve, another question, and I think you know the answer to this. Are there tools to remove the different edges, the fiducial marks and stuff on the historical photos? Do we have that as part of the workflow?
Yes, as a matter of fact, one of the driving reasons for measuring the fiducial marks is to identify the active area of the image. Once you've done the fiducial mark measurement, what ArcGIS Pro's ortho mapping does is it crops the active area of the image to be anything inside the fiducials. So any resulting mosaics do not show the black borders and the collar information in the mosaic. You can also edit the seamline data further if you need to, but yes, the mosaics don't show that collar information.
Excellent, thank you. And for those of you who don't know, fiducial marks are in older historical photos. They're little X marks or little dots on the edges of the photos. They're typically in each corner and in the center part of each edge, and those would be used by photogrammetrists to help set up the solution for the photos themselves. So we have a question from Will. Any performance issues, comparisons between D2M and OrthoMaker? And I think, Steve, you had some good results with a block that you adjusted just the other day on the OrthoMaker capability with your historical aerials.
Yes, in fact, one of the things I wanted to mention was that I use a very small data set, but I also applied this to a very large data set in Portland, Oregon, and I ran that yesterday, and that was just under 800 images. And the accuracy was very good, even with very minimal control. So it does lend itself to being able to support visual and analytical change detection. Again, the accuracy is driven by the use of the ground control points. The solutions are very good. For drone data, go ahead, Kurt.
And you were impressed with the speed as well of the process?
Yes, the block of 800 images took just under 3 hours to process, which is
excellent.
Pretty reasonable for a block that size. And these were high resolution scans. These are very large files. So So I was happy with the throughput on my little 4-processor laptop.
So, and one more final question. If we didn't get to your question, we'll try to answer them via email as well. Is it possible to export the adjustment report? I know in Drone to Map it produces as an HTML file, and you can just go in there and just copy that out. I always copy mine out and then just paste it into a, create a PDF out of it. Do you know on the ortho mapping workflow, does the adjustment report, is that something we can export and share?
Yes.
Excellent. Is the format like a PDF, or is it the same as what we would do with Drone to Map?
It's the same as what you would normally do with Drone to Map.
Excellent. Okay. Very good. Well, if you can see my screen, I've had it splashed up here about our Integrating Imagery to Drive Decisions webinar series. We have 3 more coming up before the end of the year. Next time we're going to, these things build on top of each other, so we're going to focus on using the imagery and LiDAR data to build 3D GIS. Mark kind of showed a little preview of that in the demonstration that he gave. Then we're going to switch it more over later on in the year to raster analytics. We're going to talk about our feature extraction capabilities, and then right at the end of the year, we're going to introduce the latest work we've been doing with AI and doing feature extraction from imagery. So on behalf of the whole team, I want to thank everybody who stuck with us and sat through the presentation, and we look forward to seeing you again at other webinar series. Thank you very much.